So in this unit, we're going to focus mainly on inequalities as opposed to equations. And the first couple of assignments deal with solving inequalities in one variable. And you're going to do these the same way you solve the equations. There's really no difference. The only difference being there's an inequality symbol. And your solutions, you're going to have multiple solutions instead of just one solution to these. In this first video, we're going to look at those that have that we solve by either adding or subtracting, these inequalities that involve addition or subtraction. And just like we had the addition and subtraction properties of equality, we also have the addition and subtraction properties of inequality. And all that says is that in an inequality, such as 5 is greater than 4, which is true, if you add the same thing to both sides, then that inequality is still true. So 5 plus 3 is still greater than 4 plus 3. And so on. If negative 2 is less than 0, which is true, then negative 2 plus 1, it will be less than 0 plus 1. And the same is true for subtraction. If A is greater than B, then A minus C is greater than B minus C, and so on. So negative 3 is less than 5, so therefore negative 3 minus 2 will be less than 5 minus 2. That still holds true. So we are going to solve these inequalities using the same methods we use to solve equations. And in this first set, we are just going to solve them the same way. For example, in example A, since we have x minus 17, to undo the subtraction, we add. And by the addition property of inequality, if x minus 15 was greater than negative 12, then x minus 15 plus 15, which is just x, is going to be greater than negative 12 plus 15, which is 3. So x is greater than 3. And then I also ask you to graph this inequality. So we're going to start with the number line. And as we talked about 3, 1, let's have just a couple that are around 3. And we are going to have an open circle at 3. And then we're going to test. If we try 2, is 2 greater than 3? Well, the answer is no. So then we're going to shade the opposite direction. Okay? In the direction of those numbers greater than 3. So this would be the solution. This is the graph of that solution. Now, in example B, we will add 5 to both sides, and once again, by the addition property of equality, we are left with n is less than 2, just bringing down that inequality symbol. And then to graph on the number line, we'll put a couple of numbers around 2. It doesn't matter how many. Now, since we have no line under that less than, 2 is not a solution, so again we're going to put an open circle at 2, and we're going to test a value. If we test 1, is 1 less than 2? Yes, so that is the direction we are going to graph. And again, the graphing these solutions just comes right from 3.1, which you did the practice worksheet on today. In example C, we're going to solve that by adding 3 to both sides. So we end up with 13 is greater than or equal to x. And then to graph this, we're going to put those values that are right around 13. Now, since we have greater than or equal to, 13 is a solution to this. So then, test point, and this is one of those that a test point is very important, because one mistake that students often fall into, they tend to think whenever you see a less than symbol, you always go to the left. Whenever you see a greater than symbol, you always go to the right. So many students will graph and shade to the right here because of the greater than or equal to, and that's not necessarily the case. That's why picking a test point is so important. For example, if we test 12, is 13 greater than or equal to 12? The answer is yes. So that is the direction we shade. And again, choosing that test point is vitally important. In D, we would add 11 to both sides. And when we solve this, we get m is greater than or equal to 9. And to graph this, we would put, again, a closed circle at 9, because 9 is a solution, because of that greater than or equal to symbol. And pick a point. 8. Is 8 greater than or equal to 9? The answer is no. So then we would shade the opposite direction. And finally, the last two, in these two cases, we will actually subtract the same thing from both sides to solve this inequality. So we subtract 6. And therefore we have t is greater than negative 10. Notice in all of these, all I'm doing is bringing that inequality symbol that I'm given straight down. So then, to graph this, and when we draw the number line, we have to be very careful. We put negative 10 in the middle. Negative 11 would actually go to the left. Negative 9 would actually go to the right of that. And we put, since it's just greater than, we put an open circle at negative 10. And we pick a point. Negative 11. Is negative 11 greater than negative 10? The answer is no, so then we shade the opposite direction. And finally, the last example of this video, we will subtract 12 from both sides. So we get negative 13 is greater than or equal to y. And to graph that on a number line, again, being very careful, if we put negative 13 there, negative 14 goes on the left. Negative 12 would go on the right. Be careful, make sure that they are in the right order. And in this case, we would have a closed circle at negative 13. And again, picking a point, say negative 14 to test. Negative 13 is greater than or equal to negative 14. So that is the direction we shade. In the next video, you will look at examples where we solve these inequalities by multiplying or dividing.